So in today's class, we are going to see Newton's law of gravitation. So, but before that, just have a glance what we studied in last class. So last class we studied Kepler's laws of planetary motion. Am I right, everybody? So Mr. Kepler's has given three laws regarding motion of a planet around the sun. So that is what we can say Kepler's laws of planetary motion. So Mr. Kepler is given three laws. First law is called as what, everybody? All of you?
Law of
Law of orbits, or we can say Kepler's first law of planetary motion. So according to the Kepler's first law of motion, the planets are revolving around the sun in a particular orbit, and orbit is having two axes. What is the two axes? One is semi-major axis and another one is what? Semi-minor axis. And semi-major axis is having two foci, and sun is present either any one of the foci. Sun is present any one of the foci, and planets are revolving around the sun in a
So can we call it as just major axis and minor axis?
semi-major axis and semi-minor axis. You have to say semi-major and semi-minor. Understand, Mari? Clear? So that is what the first law of orbits, also called as Kepler's first law. Second law, what is that? We used to say law of areas. So as I said, if you imagine that when the planet will start moving faster, suppose I imagine the sun is here at this focus. Now you tell me when the planets will move faster, when they are closer to the sun or far away from the sun. All of you?
Closer to
When
the
they are
sun.
closer to the sun, the speed is increases. When they're far away from the sun, the speed is decreases. So let me take in a given period of time. What is second law, everybody? In a given period of time, the planet will sweeps equal area in equal interval of time. That is what we used to call as law of areas. If I calculate this one, so let me take A1 area. In some other time, it will maybe calculated some other point. So again, a same equal interval of time, it will sweeps equal interval, equal area. So that is only we used to called as, what is to call, everybody? All of you? Law of areas. So the area covered by the planets in equal interval of time is always equal. That is only called as second law of Kepler's second law of planetary motion, which is also called as law of what? Areas. Understanding? Alfin, are you writing? Next, third one. What is the third one, everybody? So different planets will take different time period around it. What is the name of the law? What is the third law name? Law
Law of periods.
of periods. So we all people knows that. Suppose if I take planet number 1. So planet 1, it will take different time period to revolve around the sun. Let me take it as a T1, and it is having an average radius. I'm not saying radius. It is having an average radius, different radius from the sun. So that is what, let me take R1. And if I take a planet 2, it is having a different time period and different average radius. So let me take it is a T2 and this is T2. Now, if I do the square of time period is always directly proportional to cube root of radius. If I find this one, T1 square divided by R1 cube, I will get the what? Everybody? I will get the constant. For second planet also, if I do, that is also T2 square divided by R2 square also, R2 cube also. R third planet, T3 square divided by R3 cube remains, we will get the same constant. So that is what we used to call as law of periods. So the square, what is law of Kepler's third law, everybody? What is Kepler's third law? The square of the period of revolution of a planet. That is what time period. So the square of period of revolution of a planet around the sun is directly proportional to cube of the average radius of the planet's orbit. So that is what is we used to say T square is directly proportional to average radius of the cube root of average radius of the planet. So this is only Kepler's third law, which we studied in our yesterday's class. Am I right, everyone? Please respond. All of you? Yes.
Yes, sir.
Now, if you have taken in our today's class, we are going to see the most important law for your exam also. So that is what we used to say, Newton's law of gravitation. So, or we can say universal law of gravitation. Whatever you want, you can write it. We can say universal law of gravitation. Okay, are you clear, everybody? Newton's law of gravitation, or we can say what? Universal law of gravitation. Now, so what makes Mr. Newton to derive this? Who inspired him? So that is what,
Kepler's theory.
yeah, we'll make it now. Okay, so all of you observe very carefully. Newton's law of gravitation will says that. So how he has been inspired means, so he has noticed that when you throw a ball up, what will happen, guys? Suppose I am on the
So on
earth.
road, sir.
Yes, Mari.
Sir, it is also known as what, sir?
Universal law of gravitation. Clear?
Sir.
Yeah. So you can see from the, suppose I am standing on the earth, if I throw the ball upwards, so after traveling certain distance, what is happening, guys? Anybody? Yes, please.
So the ball comes
Again
back.
started falling down again. Am I right or wrong? So if you throw a ball up,
Yes, sir.
it will go to a certain distance, upward direction, and it will be falls down again. So according to the Newton's first law of motion, we all people knows that. According to Newton's first law, second chapter. What is Newton's first law? Anybody? Yeah, law of orbits. What nonsense are you talking? Yes, law of inertia. So what will happen, guys? All of you, when a body will move, anybody can tell? So Newton's first law will says that the body which is in rest remains in state of rest. The body which is in motion in a uniform, that is what? Uniform motion in a straight line, continues its motion unless and until they have been compelled by an what forces? Compelled by an external force. If you don't know first law also, what I can do? So that is what Newton's first law of motion will says that the body at rest moves only when, guys, if you want to make the body to move, we need balanced forces or unbalanced forces. Everybody.
Unbalanced force.
Unbalanced forces. We need unbalanced forces to make the body to move. Now, if I throw a ball, after traveling a certain distance, body is coming down. So the net force is 0 or not 0? Anybody? Net force is 0 or not 0? Please respond.
Not 0, sir.
Not 0. So the net non-zero external forces is acting on it. So then only the ball will went up, and you can see if the ball wants to go up, who is applying the force? Anybody can tell me? The boy who is standing, who is thrown. The boy who has been thrown the ball, he is applying the force. So that is why the net force is 0 or not 0. Everybody. Net force is not 0. So that is the reason ball is started moving upward direction. But why did it fall back? Which force is responsible for it? That is the question now. Yes. So these questions troubled Mr. Sir Isaac Newton. He has been thrown the ball upward direction. Oh, that's fine. It's great. Because net force is 0. A boy is throwing. So the force is applied by a person. So that is the reason it is going upward. Then why it is coming downward? Who is responsible for it to bring its body back to the ground? That is what Mr. Newton observed an apple falling from a tree. Very popular story. You might be heard it. Am I right or wrong? That is one of the apple which changed the world much. So there is a 3 apple story might be. So when he observed an apple falling from a tree, he concluded that Earth must be exerting a force of attraction on the apple, and hence that is how it will get accelerated towards to the earth. That is what he has been observed. But this force is existed between only this body is between earth and the any other object? No. But later only he has noticed that the force of attraction not only between the earth and the objects, any objects, any two bodies, anywhere in the universe, that is why it is called, he called that is called as force of gravitation. It is happening not only the earth, not only earth is the stone is falling. Every object in the universe, this force is existed. That is why it is called as, what is to call, guys? Force of gravitation. It is not a gravitation. What is this actually? Who is to called as force of gravitation.
Force of gravitation.
So, Mr. Sir Isaac Newton studied the gravitational force between the different bodies in the nature, and proposed a law to account for the magnitude and as well as direction of gravitational force between any two bodies. All of you remember magnitude of mass and as well as direction of gravitational force between any two bodies in the universe. So that is only called as law of gravitation. And you remember this is applicable to any two bodies in the universe. Applicable to any two bodies.
I can please repeat it again.
Yes, in the universe. Remember the law which has been describes, it will describe about the two things. What is that? Magnitude and the direction of gravitational force. How much force and what is the direction? So between any two bodies in the universe. So that is only called as Newton's law of gravitation, or we can say universal law of gravitation. It is applicable to any two bodies in the universe. It is not belongs to particular part. So that is why the gravitational force of attraction between the two bodies, any two bodies in the universe, is directly proportional to the product of their masses. The force of attraction symbol is F. So according to the universal law of gravitation or gravitation, Newton's law of gravitation statement, I will say you, the force of attraction between any two bodies in the universe is actually product of their masses. So let me take one mass is capital M and another mass is small m. So that is what the product of their masses, directly proportional to product of their masses and inversely proportional to the square of the distance between them. So inversely proportional to square of distance between them.
Sir,
So
I cannot
here
understand.
D means distance. You remember, you take any two bodies in the universe, so they will be having a center. So from the center, if you find the distance between them, that is what we used to call as D. I am assuming as any two bodies. You take any two bodies in the universe, calculate the distance between the two bodies from the centers. From the centers, and the distance I am assuming as a what, guys? Everybody? D. Distance between two bodies, I am writing two bodies from their center, from their centers. That is what we used to call as D. So according to the Newton's law, universal law of gravitation, the force of attraction between these two bodies is directly proportional to product of their masses, means M into M, and inversely proportional to square of distance between the two bodies from their centers. So that is only called as universal law of gravitation, or we can say Newton's law of gravitation. So here
Sir, I
D,
cannot understand, sir.
what is D means? Distance between the two bodies from their centers. What not understand, Mari? You can take any two bodies in the universe. I have taken this body. I have taken another body. So it is present somewhere. You can take any two bodies, either it is a celestial bodies or terrestrial bodies out of the earth or inside the earth, wherever you take it. So mark the center of the body and mark the center of the body. Find the distance between them, between the two bodies from their centers. So this is the center of the body and this is the center of the body. I calculated the distance between them and I marked it as a D. The distance between the two bodies from their centers, I marked it as a D. And I assumed mass of this body is capital M and mass of this body is small m. Mass of this body is capital M and mass of this body is small m. Now the force of gravitation, that is what the force of attraction. The force of attraction present between these two bodies. Force of attraction present between these two bodies is directly proportional to product of their masses, means multiplication. Both masses, if you multiply m into m, so the force of attraction is directly proportional to their masses. Means mass of the bodies increases, force of attraction also increases. Now see, F, both masses are increasing, m also increasing and small m also increasing, both bodies, then force of attraction also increases. If mass of the body decreasing, understanding, then force of attraction also decreases. Either two bodies or even one body. Either two bodies or one body. So anything, either it is mass increases, force of attraction also increases. Mass decreases, force of attraction is decreasing.
Can we say force of attraction as gravitation?
That's what force of gravitation, only force of attraction.
Yes, sir.
Understand? Now, and the distance between them we have been assumed as a D. Distance between them, not from the surface, from the center. From the centers, the distance between them is D. So this force is actually, the distance is also affecting the force of attraction. So how it will be affecting means, force of attraction is inversely proportional to, inverse, it is not direct, inversely proportional. What do you mean by inverse? 1 by. So inversely proportional to square of distance, not narrow distance, square of distance between the two bodies. So from their centers. So that is what it will be happening. Means distance is increasing. Suppose now two bodies are 1 meter distance. Now the same two bodies will go to 2 meter distance. Same two bodies will come to the 3 meter distance. The force of attraction is remains same or different? Everybody? The force of attraction is remains same or different? Different. Do you understand it? So distance increases. The distance between the two bodies from their centers is increasing. Then the force of attraction will start decreasing. How much it is decreasing, that is all we'll discuss. Okay, we'll solve it also in our today's class itself. Okay, all of you. So that is what is called as inverse. This is only called as, also we can call as inverse square law. Okay, actually this is derived from Kepler's laws. We will discuss in our tomorrow's class. So inverse square law, if you remember.
Sir,
Yes.
sir, then can we say it as m into m by d square?
Yes, Mari. Wait, I will say. So inverse square law. This particular one we used to call it as inverse square law. So force of attraction between two bodies is inversely proportional to square of distance between the two bodies from their centers. That is very, very important. So you can see that this body's force is exerting towards this body, and this body is also exerting force towards to this body. So the force of attraction present between them is depends on distance between them and as well as mass of the bodies. So that is what is the two factors. Now, if I combine these two, equation 1 and 2, I'll get a common equation. So F is directly proportional to product of their masses and inversely proportional to square of distance between them.
Sir, I'm
That
having
is
a doubt.
only. Now, why, sir, you are saying a inverse square law means that law is called as inverse square law. How Newton guessed this? Is not simply said. He derived from it from Kepler's laws. That's what I'm saying. Tomorrow we'll study inverse square law. It is inverse and square of distance. That is what we used to call as inverse square law. They have kept a name. Yes, Mari.
So in the previous image,
Tell
you
me.
have given two masses, sir.
Yes.
Is it acting opposite to each other like you have drawn two rays?
I have not drawn two rays. It is force of attraction. Suppose
Yes,
we have
sir.
studied
Yes.
collision, moment of collision. If two bodies are moving, whatever the direction they are present, this body is exerting force on this body, and this body is exerting force on this body. That's what I am saying. Nothing is there. The
Yes,
force
sir.
exerted by first body and second body, and force exerted by second body and first body. That's all.
Yes, sir.
Understanding? The first body will exert force on second body in this direction. That is what you can take it. Force exerted by first body and second body. Second body will exert opposite direction. The force exerted by second body and first body is F21. That's all. Nothing is there. Understand?
Yes.
Okay.
Yes.
So now.
And the
Tell me.
magnitude and direction of the gravity is known as Newton's law of gravitation, sir.
Newton's law of gravitation will help us to find the magnitude and direction of force of attraction, both. How much force and what direction it is acting. Okay.
Yes, sir.
That is what is universal law of gravitation. Will help us to find the magnitude and as well as what direction of force. That's all. So
Yes,
now,
sir.
if you remove the proportionality, so what will happen? We'll take it as a constant. So equals to into constant into capital M into small m divided by d square. So this constant only we used to called as capital G. So called as universal gravitational constant. Universal gravitational constant. Okay. So make it capital G. And if you make it, so the formula will be modified into F is equals to capital G into capital M into small m divided by d square. So this is what is actually the formula for universal law of gravitation.
So this is to find the force of attraction.
Force of attraction between any two bodies in the universe. Any two bodies in the universe. Are you clear, everyone?
Yes, sir. Sir, according to gravitation, the constant's value will be differs, sir.
Which one value? No, that G value is always remains constant. Universal gravitational constant. That value also we can calculate it. We just make it. Okay.
Yes, sir. In the previous chapter, you are kept as K, sir, which is K is equal to 1.
That is their constant. That is Newton's. That is another one. That is another concept. This is G, universal gravitational constant. Values are different. Different constant is having different values. It's not all constant. Understand?
Yes, sir.
Yeah. Clear, girls? Shivani?
Yes, sir.
Gokul?
Yes, sir.
Alpin? That is what. So nothing. Any two bodies you take in the universe, the force of attraction between them is directly proportional to masses and inversely proportional to square of distance between them. That's all it is. So I can say the force of attraction these two bodies is equals to capital G into capital M into small m divided by distance between the two bodies from their centers. So that d square. Are you clear? Okay, everybody? Please respond. So that is what is called as universal law of gravitation. Now, let us write the units. So we can see units of this one. So F is equals to G into, so let me take mass. For example, I will take it 1 kg mass. How much it is mass? 1 kg. I take another mass is also 1 kg. Sir, what is the force of attraction between them? How much it is acting? They are present at 1 meter distance from their centers. How much distance, everybody? Please respond. How much distance? 1 meter distance. Then means capital M is equals to small m, which is equals to 1 kg. So how much it is? Check it. G into 1 kg into 1 kg divided by 1 meter square. So we all knows that F is equals to capital G into 1 kg into 1 kg. What is that, everybody? Please respond. 1 kg into 1 kg.
1
kg,
kg square.
yeah, kg square divided by meter square. So that is what is the force of attraction. So we all knows that. What is the force, anybody? What is the units of force? Units of force. Yes,
Newton.
please. Units of force, newtons. So we will get, if two bodies are kept at 1 meter distance and their mass is 1 kg. So remember, I will prove it. So F is equals to G newtons. How many newtons is acting, everybody? How much force of
G
attraction
newtons.
between G newtons? So what is this G? The G is only called as, what is that called as, everybody?
Universal law of gravitation.
Gravitational universal constant, not Newton's law of gravitation. Understanding? So capital G is the universal gravitational constant.
So one doubt, sir.
Yes,
How did you got G Newton, sir?
that's what. Wait. Listen first. Universal gravitational constant. Are you clear, everybody? So we can say the G can be defined as the, what is G? All of you check it. So G is defined as the gravitational force of attraction between two bodies. Mr. Sanjay, here you have to remember. You might be remember, I have taught you the G value is equals to 6.67 into 10 power minus 11 Newton square meter per kilogram square. Do you remember, Mr. Sanjay? Girls, I think 10th B and 9th
Yes,
B
sir.
and 9th C. Yes. So now remember, this value has been derived by a scientist name called as Henry Cavendish. So how this value is derived? With the help of this only. So G is means, if I take a two bodies whose mass is 1 kg and 1 kg, 1 kg and 1 kg, and they have been kept at 1 meter distance, then the force of attraction between them is equals to G newtons. So that is what. So what do you mean by G newtons here? G newtons, if you have taken, so the force of attraction, the gravitational force of attraction between two bodies, each of how much mass, everybody? Each of how much mass, guys? 1 kg mass. That is what we can say unit mass, and separated by what distance, Laksha? 1 meter distance. Means what distance? Unit distance. So if two bodies of unit mass and separated by unit distance, then the force of attraction between them is G newtons. So that is only called as G. That value is 6.67 into 10 power minus 11 Newton meter square per kilogram square. Sir, how it will come? So we will get it. You can see. So we all knows that F is equals to, what is the formula? Everybody tell me, what is F is equals to formula?
M
Yes.
into M
G into capital M into small m divided by D square. Now I want G formula. So G is equals to, what will happen? D is in division, will come this side, multiplication. So F into D square is equals to G into capital M into small m. Now I want G. So G is equals to what, guys? Anybody? F into D square divided by capital M into small m. Now you can see G units. What is the unit of force? Respond. What is the unit of force?
Newton.
Newton. Understanding? Into. What is the unit of distance? What is the unit of distance? Meter. So meter square is there. So square divided by mass unit, kilogram. Mass unit, kilogram, which is equals to Newton square meter per kilogram square. Understand, Ra? Lingesh, Kishore? So units of G is equals to Newton square meter per kilogram square. Please speak 2-3 times, then only you can remember. Units of G is Newton square meter per kilogram square. Newton meter square per kilogram square. Okay. Now we got it here. Mr. Mari is asking how G newtons will come. Again, you can see, as I said. So two bodies of unit mass. Two bodies of unit mass means what is the mass of them, everybody? 1 kg mass,
1 kg.
1 kg
1
mass.
kg.
And their distance is separated by how much distance? Unit
1
distance.
meter.
What is unit distance? 1 meter distance. Then F is equals to, check it, G into 1 kg into 1 kg divided by 1 square. So we will get F is equals to what, everybody? G. Am I right or wrong? All of you understand? Please respond. Yes, Nivedan? Are you clear?
Sir.
Yes. So F is equals
Yes,
to
sir.
now G newtons. Sir, how sir G newtons? You can see that. What is the units of G? Anybody can tell me? Units of G. Newton square meter per kilogram square. Correct? All of you respond, Ra. Newton meter square per
Yes, sir.
kilogram square. So I will replace it. Newton meter square per kilogram square into kilogram square per square meter. So kilogram square get cancelled. Meter square get cancelled. What is left? What is left? What is left here? Newton.
Newton.
So Newton is the unit of what? What is the Newton? Unit.
Force.
Force. That is what it is. So if two bodies of unit mass, is separated by 1 meter distance, 1 meter distance, then what is the force acting, Mr. Lingesh? The two bodies, what is the force acting? Force acting between them is how many newtons, guys? G
Newton.
Okay, so that is what you have to remember. Very, very important. Clear? Anybody having doubt, you can ask.
Sir,
Hmm.
sir, force is equal to G newtons when the values are unit mass.
When the two bodies mass is unit
Unit.
mass and the distance between them is 1
1
meter.
meter.
Unit distance. Unit
Yes.
mass and unit distance. Hasini Sudhakar, understand? Yes? That is what. Okay, everybody. So this is what
Sir,
we
at
want.
the
Yes. Tell me.
sir, the image you have shown, no, sir, the two objects which are acting force opposite to each other. Is there is any real life example for that, sir?
Mari, everybody, Mari. Suppose now you are sitting in our home, I am sitting here. In between you and me also, there is a force of attraction. Do you understand?
Yes, sir.
But I am not
Is there
falling
any
towards you.
downward force of attraction, downwards?
Any direction. You are in above from the ground or in the same surface. Any two objects. Now you are sitting in front of in our home. Your home and your home and you, your walls and you are having a force of attraction. Your fridge and you are having a force of attraction. You are sitting in a chair. Your chair and your ground is having force of attraction. Whatever the two objects in the universe, they will be having a force of attraction.
In any direction.
Any direction, any two bodies. Suppose if
Yes,
I take
sir.
three objects, suppose here one body, here one body, here one body. These two are having force of attraction. These two are having force of attraction. These two are also having force of attraction. If there is a fourth body, these two are also having force of attraction. These two are also having force of attraction. Do you understand?
Yes, sir.
Any bodies, any direction, they will be having a force of attraction between each other. Any two particles in the universe, they'll be having force of attraction. Clear?
Yes, sir. Sir, then what is the unit for force of attraction, sir? The whole
Newton,
form.
that is what I'm saying. What is the unit of force, Amma? Everybody? What is the
Newton.
unit of force? Newton. Force of attraction is Newton only. Understand?
Yes, sir.
Yes. Shivani, are you clear? Alvin, I'm
Yes,
calling
ma'am.
you only. Mr. Darshan,
Yes, sir.
Abhirami?
Yes, sir.
Yes.
Sir.
Please make it. And Mr. Newton cannot find the G value. And see that SI unit of G is Newton square meter per kilogram square. What about the CGS unit? That is very important. What is the CGS unit of Newton? Anybody? Force. CGS
Dyne.
unit of force. All of you. Dyne. Write it. Meter, distance. Distance we can measure in what? Centimeter. So centimeter square. Kilogram we can measure in what? Grams. Gram square. So this is the CGS unit of force. Dyne centimeter square per gram square. Please write it. Dyne centimeter square per gram square. This is the CGS unit of G. And SI unit is Newton meter square per kilogram square. Laksha, what do you want, Amma? Abhirami, are you understanding?
Yes, sir.
Any doubt, ask me. Mr. Mukesh, Sam, no response, no use. Agalya also. Niroshini, are you clear?
Yes, sir.
Okay. Do it, everybody, seriously.
This is the formula for gravitation, sir. Is it the formula?
Force of attraction. Force of attraction between any two bodies.
Yes, sir.
Clear, everybody? Now, this G value cannot be found by Newton. This value after about 100 years later of this formula. Which formula? F is equals to G into capital M into small m divided by D square. After 100 years of this discovery, this formula, so it has been found by almost 100 years after. The G value has been found by Mr. Henry Cavendish. He is a British scientist. Okay. So some books they'll say 40 years, some books they'll say 100, but actually it's 100 years only. So after 100 years of Newton's universal law of gravitation, so Mr. Henry Cavendish is find the accepted value of G, which is universally constant. The G value is actually 6.67 into 10 to the power of minus 11 Newton square meter per kilogram square. So this is the G value which is universally constant. So please make it. Anything doubt you can ask. Newton's law of gravitation, capital G, universal gravitational constant. Universal gravitational constant. What is G? G means, all of you, the force of gravitation between how many